In this video, we want to see how I can convert the voltage in millivolt that I measure it as a result of the temperature increase at the tip of the thermocouple, how I can convert that back to the temperature, because the objective, I'd like to know what is the temperature at the tip of the sensor or the thermocouple. So here, if you look to the voltage that we have here, it is very small, around 0.02 millivolt. Why is that? Because the temperature gradient between the tip and the other end where you connect your voltmeter probes is 0, because the temperature here and there is exactly the same. So there will be no voltage difference. The only way to have a voltage difference, then you have to increase the temperature of this side. So let's see, I touch it here, and let's see here, look here what is happening. The voltage start to increase, not much, but increases 0.16, 0.17, 0.18, 0.2 millivolt, 0.22, and so on and so forth. So it keep on increasing. And of course, I can have a source of heat here, and we'll go even more than this. Okay, so that's not the point. The point we want to see how I can convert this voltage, let's say the 0.2 millivolt, into temperature at the tip of the thermocouple. And to do that, we need to use the data sheet of the thermocouple. The thermocouple that we are using here is called K-type. Okay, so there are different types of thermocouples. We have to know which type we are working with, so that we will be able to do the conversion. So this is the table here, as you can see. So this is the type K thermocouples. Okay, and here is the calibration between the temperature and the voltage in millivolt that we are measuring. So here in this column, we have here the temperature in gradient or difference of 10, 0, 10, 20, and here of 1. So for example, if you want to find at 22 degree, what is the corresponding voltage? This is 20, this is 2, so it is 0.879 millivolt. So this is how we can find the corresponding voltage from the temperature. Okay, now let's go to the question we asked. We measured, let's say we measured 0.2 millivolt. So this is the voltage that we measured due to the increasing the temperature at the tip of the thermocouple. How I can convert this into a change in the temperature? Remember, this 0.2 millivolt is due to what? A temperature difference between the two. It's not the absolute temperature. It is the temperature difference. Okay. Now we were at room temperature. Okay. So the room temperature was around 22, 23. Let's say it was 23 degrees centigrade. If it's at 23, so the voltage corresponding to this is 0.919. We call this the voltage at T reference is equal to 0.919 millivolt. So this is the voltage due to what? Due to the reference point, which is the other end of the probe. Okay. Now what we measured is 0.2 millivolt. This is what we call it V measure. This is what we measure. We measure is 0.2 millivolt. Okay, so we have here two voltages, the 0.2 and the 0.919. The 0.919 millivolt is due to the reference temperature, and the 0.2 millivolt is due to what? Is due to the ingredient or the increase in the temperature. Okay, so now the total voltage, we call it the V hot, is the summation of the two, which is 1.119 millivolt. Now we want to find what is the temperature correspond to this voltage. So we come here, 1.119. It's between this voltage and this voltage. Okay, so it means that the temperature is between 27, here is 20. We come here, this is 20, and here's 7, and 28. So something in between. We can use linear interpolation to find the exact temperature. So it will be 27 point something. This is how we convert the measured voltage at the tip of the thermocouples into actual temperature, knowing that the thermocouple always measure the temperature difference between the sending end and the receiving end.